Going on to the multiplication rule for independent events. So if we want to know the probability of E and F occurring, this is going to be the probability of E times the probability of F. And this is when your events are independent. Let's look at an example. In a game of roulette, the wheel has slot numbers 0, 00, and 1 through 36. A metal ball rolls around a wheel until it falls into one of the numbered slots. What is the probability that the ball will land in the slot numbered 17 2 times in a row? So what we want to know is the probability of 17 on spin 1 and 17 on spin 2. So since these are independent, one roll does not affect the other, we can find the probability of getting 17 on spin 1 is 1 out of, here's 36, 37, 38 possible chances, and then times that by getting a 17 on spin 2. So that's 1 over 1,444, which is about 0.0006925. So about 7 times in 10,000 trials. We know you can multiply by 10,000 to get 6.9, so that's why it's 7. Or another way to know it's 10,000 trials is that this is the tens, hundreds, thousand. This is in the 10,000 spot. Find the multiplication rule for n independent events. So up above we just did 2. What if we had more than 2? Take the probability of E1 and E2 all the way up to E sub n. That's a probability of E1 times the probability of E2. So basically, you're just going to multiply all the probabilities together. Let's look at an example. The probability that a randomly selected 24-year-old male will survive the year is 0.9986. A, what is the probability that 3 randomly selected 24-year-old males will survive this year? So we want the probability that the first survives, and the second survives, and the third. So since these are all independent, we can take the probabilities of each and multiply. So the probability that the first survive is 0.9986, same for the second, and same for the third. You can also write this as 0.9986 to the what power? This would be 1, 2, it happens 3 times, so to the third power. If you do that on your calculator, you should get 0.9958. What is the probability that 20 randomly selected males age 24 will survive? So we want probability all 20 males survive. So we're going to take 0.9986. Instead of writing this out 20 times, I'm just going to raise it to the 20 power. Let me show you how to do this on the calculator. And then this little button here, it's called the caret key. And you do to the 20th. So 0.9724.